The growth of duckweed on a pond is being studied. The surface area of the pond covered by the duckweed A meter square at time t days after the start of the study is modeled by the equation. This is the equation A is equal to P Q power T, where P and Q are the positive constants. Figure 1 shows the linear relationship between log 10A and T. It means on that side log 10A is taken and on this side T is taken. Mean y-axis is replaced with log 10A and x-axis is replaced with T. So first of all, in the given relation, the relation is given for area, that is A is equal to PQ power T. We have to find it in this term. So I will write here in this area. So even the graph will be in front of me. If we need, we can use that also. So it's given that A is equal to PQ power T. So first I have to make a log to the base 10. Remember one thing, if I write log to base 10 or I just write log 10, both are equivalent, because usually in writing base 10 we don't write. So that's why I will not write also. I will take on both sides log on both sides, so I can get, because that's right now is A, but the relation is given for log 10A. So that's why I take logarithm on both sides. It will become log of A equals to log of PQ power T. So that will become log of A equals to, now apply the logarithm rule on that, it will become log of P plus log of Q power T. That can be log of P, log of A will be equal to log of P plus T can be, this is the property of the logarithm, that log A power B we can write as B log of A. So T I can write, it will become T log Q. So rearrange it a little bit, it will become log of A will be equal to log Q into T plus log of P. Now compare it with the equation of the line. If we draw between x and y axis, equation of line will be y is equal to mx plus c. Where the coefficient of x will be is called gradient. So in that case, it means what is the gradient? This log q is equal to the gradient. Log q will be gradient. So to find the value of and what is this one? This is the y-intercept, because this t is the y-intercept. So this is the graph between log and t. So that's why the coefficient of t will be, I will say the coefficient of t is gradient, and this is the y-intercept. Okay, what is the y-intercept? Y-intercept is, in this case you can see y-intercept is 0.32. So what you will do, you will put log of p equal to 0.32. And in the same way, log of q, the gradient. For gradient, what you will do, you can say your log of q will be equal to the gradient. 2 points are given, so gradient you can easily find. y2 minus y1 over x2 minus x1. So that can be 0.56 minus 0.32 divided by 8 minus 0. So that will be log of q here. I will get, if I will solve it, let's say 1 second, let me open the calculator. Okay, let's solve that now. It will be 0.56 minus 0.32 divided by 8. So we'll get 0.03. So now from this one I will get the value of P, and from this one I will get the value of Q. Let's solve that now. What P will be, if I will take this to the other side, so it will become 10 to the power 0.32. So what P will be 10 to the power 0.32. So that will be 2.089. And it should be to 3 decimal place. That's why I will write 2.089. 0.089. Okay, for Q, what I will do, Q will be, when I will take this log, as this is the log with base 10, so it will become 10 to the power 0.03. So Q will be 10 to the power 0.03. It will be 1.072. These are our values of P and Q that we found. Now, once we found the values of P and Q, now what next we have to do, second. Now next is find the rate of increase of the surface area of the pond covered by the duckweed in meter square per day exactly 6 days after the start of the study. Now this is equation for area. Area is PQ to the power T. Now what we have to first put the values of P and Q, because that we found already. The value of P is 2.089 and value of Q is 1.072. Put these values here. What A will become, it will become 2.089 into 1.072 to the power T. Now we have to take the rate of increase of the surface area. So what is the rate of increase? Increase means rate of change. So first takes rate of change, and it means we have to take the derivative of this one. It's depending on T, so that's why it will be L. We have to take the rate of increase, so dA over dt. This is constant, right, as it is. And for this one, use this formula. If you have y is equal to a power x, so what is the formula for the logarithm of y is equal to a power x? If I take dy over dx, it will be, we'll say it's going to be a power x log of a. Apply that formula on this one also. It will become 1.072 to the power t in this as it is, and then into the log of natural logarithm of whatever is the base here. It is 1.072. So from here I will get now I have to find exactly after 6 days. So what I will do, in place of t I will put 6. So put t is equal to 6. So what will be dA over dt? It will become 2.089 into 1.072 to the power 6 log of 1.072. Okay, let's calculate that now. Again, I need to share the calculator. Okay, let's say it will be 2.089 into 1.072 to the power 6 into log of 1.072. So it will be 0.22. To 2 decimal places we have to write, so 0.22. That will be, I will say that is going to be 0.22 meter square per day.